To get scene CSV of Aurotek A-iR6 6-axis robot. This robot is designed by A-iR6 for Aurotek by using Panasonic model and reduction gear. We get a video to show the motion of a robot, and we designed the inverse mechanism to translate the Cartesian of the TCP point to translate into 6-axis movements. According to the video, we get the first axis rotating around z-axis positive with left hand rule. The second axis J2, J3, J4, and J5 and J6. The A-iR6 dual controller for Aurotek. This is the way A-iR6 does. The J1 with right hand rule. The positive is this side. The second around the Z, the y-axis positive. So the sum directions point this direction. And 4 fingers turn around the y-axis. So the J2 plus is this direction. The J3 is around y direction as well. So J3 is this direction. The J4 around x-axis. X-axis is this direction. The sun point to the positive x direction. The 4 fingers turn around, point to J4 plus. The J5 turn around y positive direction. So the J5 positive is this directions. The J6 turn around z x positive So the J6 positive is these directions. These 6 axes all turn around according to the right-hand rule. This system is designed by A-iR6 for Aurotek. But after we survey the FNAC rotation for FNAC robot M710, the first axis turn around Z positive direction with right hand rule. The thumb point to the sky and the forefinger turn around. The J1 is positive, is alright. This direction is Y positive. The thumb point to this direction, while the 4 fingers point to J2 positive. It's okay. It's right hand rule as well. But for J3, J4, J5, J6, you can see the J3 suppose turn around the Y positive. The thumb point to this direction. The J3 positive should be this direction, just like J2, but J3 is totally different, opposite direction against the J2. The J4 turn around x-axis. If right hand rule, the J4 should turn this direction, but you can see in here FNAC is inverse. It is left hand rule. The J5 turn around Y positive. If with right hand rule, the positive direction should be this direction. But you can see in here, inverse. It is left hand rule. The J6 turn around X positive. The right hand rule, the J6 positive should be the opposite direction. The conclusion is FNAC, the first 2 axes, J1, J2, with right hand rule. J3 to J6 with left hand rule. For another extra example, in here we found in the web. This is FNAC robot. This is x-axis, this is y-axis, this is z-axis for Cartesian coordinate. The first axis, J1, turn around z positive direction. With right hand rule, this direction is positive. The J2 turn around y positive axis. With right hand rule, this is positive, it's okay. But J3 is turn around the y-axis as well, but the positive direction. just totally different, opposite to J2. The J4 turn around x-axis. The positive should be in this direction, but you can see in here is minus direction. The J5 is totally different. It is left hand rule. The J6 is left hand rule as well. With these two examples, we know the finite Loba, the J1 and the J2 with right hand rule, the J3 to J6 with left hand rule. So we can get a conclusion. If any movement is different, then the inverse mechanism is totally different. The inverse process is with the TCP points SYZ, RX, RY, RZ, and with calculations to get J1 to J6 turning degrees. If any join turning the different direction, then the inverse process is different. With so many combination for the 6-axis, for CMS CAPP, the first requirements to do the project is according to the video tab. Doing the 6-axis is with left hand rule. So we better keep the same way until we get really projects, the really requirements. Then we have to adjust our inverse calculation. Not in these moments, because no one is right, no one is correct. No one is strong enough as the standard of the world. So we better follow the original requirements to continue our controller. The 6th LOBA is very important for join mode and very important for Cartesian mode. In here, we press, then it will change to the Cartesian coordinate system. A Cartesian coordinate system will base on the TCP points, RGB errors. R is axis. If we touch X positive, it will moving along the direction of R arrow. The Y, the X negative, the X negative will go another direction of the red arrow. The Y positive will follow the green arrow. The Y minus will go the opposite direction. The Z as well, positive, negative. While RX positive the X arrow, no movements. If you're turning according to the right hand rule, the sun to point to the red arrow's direction and turning right hand rotating. Rx relative, you can see this arrow, this points, no movements, the rest turning around. And to get the inverse J1 to J6 of the robots, RY positive, RY negative, RZ positive around the blue arrow, positive right hand turning, RZ minus. Okay, this is requirements of the Cartesian coordinates systems movements. We'll go back to the original Aurotek A-iR6 robot. According to the SOP, we have to get IGS of any mechanism before we doing the usage in our CMS CAPP. Whenever we adopt a robot, we have to get its IGS file or step file of the mechanism's geometry structure before doing Industry 4.0 3D simulation. Then we go to SolidWorks. According to the SOP, we have to open an old file, the D Aurotek to get A-iR6 point IGS. Open it. The SolidWorks will translate the geometry model into the system. After translation, the model geometry will display on the screen. We can survey it if it is correct, or YZ with wrong direction. You can see S direction here, Y direction, this direction. The Z point to the sky. So this A-iR6 is in correct position. And the original points in here is at the bottom of the foundation. The Z point to the sky. It is correct. As the model in 3 pieces in color, the rest all white. Then the 3 we keep its original color. The rest we color it with yellow. Okay, let's continue to separate the geometry of the 6-axis robot into components before translate into X file, we have to prepare the IGS file of every components. First of all, we have to save the file as a .asm file, assembly file. Still, we give the same name A-iR6 and save it. Save all. Then we start it from the basement, from this one. This one here, he say, is J1. According to our naming regulation, the foundation, we call it 0. This J2, we call it J1. Okay, we started from this one. We remove the rest of J1. To press the left button of the mouse at first and move the cursor to J3 and press the shift key of the keyboard and press together the left button of the mouse to mark it all. The rest we just pick one by one by pressing the control key of the keyboard together with the left button of the mouse, one by one, until the total marked. Then we can remove the marked parts by press the delete key of the keyboard and choose delete all and left the foundation on the screen. Then we change the color of the foundation by putting the cursor on top of the component and press the right hand button of the mouse and choose the out looking and pick the white square. We say we choose the yellow, so we pick the color yellow. If everything by picking, then the 6 component must with a little different colors. So we better to press correct pixel color. For red, we say 255. For green, 255. For blue, is 0. Make sure. Okay, the component of the foundation settled down. Then we save another file with the type .prt with the name AJ0 AJ0 and save it. And then we save another file with the type IGES and then AJ0.IGES and save it. So the foundation finished. Then we close the old file, no saving, to clean the screen and use the file to open A-iR6 the assembly model and pick the second one and doing the same process, and to save AJ1. AJ2 is the original. In our name is AJ1. Before saving it, we have to change the color into yellow and save AJ1.prt and save another file, AJ1.iges. AJ3 as well. Remove the rest of the component and change the color of AJ3 to yellow and save a new file as AJ2.prt and then save another file, AJ2.iges. This AJ4 as well. We remove the rest and keep AJ4 only, and then change the color into yellow and then save it. Use another name as AJ3.prt and then save another new file, AJ3.iges. AJ5 as well. We combined this one, AJ5, write protector, and this one, left protector. These three combined into AJ5 and remove the rest of the components and change the color of this one and save another file name as AJ4.prt and then save again another name, AJ4.iges. This one, AJ6 with model. These two components, we left them on the screen and remove the rest of the components and change the color of them into yellow and save another file name as AJ5.prt and then save another file name as AJ5.iges. The last one is this one. We keep this one on the screen. Remove the rest of the assembly logbar and then don't change any color because the original given colors there, and save another name as AJ6.prt and AJ6.iges. Now, one more we have to do is to draw the tool. This one is a tool of CO2 MIG. Now we intend to draw this tool in SolidWorks. Suppose from here to here is 200 millimeter. From here to here is 50 millimeters, rotating 330 degrees. Now we draw the tool on SolidWorks. Before drawing, we have to close the old file, no saving, and open a component and choose a direction. We choose XZ direction. SZ direction. Okay, this is SZ direction. The original points in here. So the tool, just like this way and this way. Suppose Z is pointing to sky. So the join should be this way and down. Okay, let's continue to draw the tool. After we choose the base surface, the standard surface, then we can open a sketch. Okay, let's do it again. SZ and open a sketch. Then we change it back to Z, point to up, and we pick straight line. Started from the original and going 200. To these points. You can see at the left button there are a distance 200.3097 and degree is 0. Use the mouse, we give the arbitrary coordinates not correct enough, so we can use keyboard to correct it into the correct value. But we have to press the left button to make sure first. After press the left button, don't move the mouse. Then we can use the keyboard to change 200.31 into 200. The correct value. Okay, let's press the left button and you can see the highlights at the left button 200.3097. Okay, after we move the mouse, we cannot change any value because the display changed. So we close it to do it again. If not pick the base foundation, the system not allowed us to do any join. So we have to pick first normal, to pick a foundation surface first, and then choose sketch function. The Z point down, we have to pick it again, so we can join a sketch these moments by picking straight lines. Started from the original, go to the left 200. Move again. So we doing again. Now we concentrate on doing this one. Okay, this 200 and 0 degree horizontal, and then move 50 just around. Let's press the button in here. The 200 is keying by the keyboard. How to change from 200 to 30 degrees? By simply press the tab key of the keyboard. It will change to another parameter of the rotating degrees and the keying 30 degrees. So the geometry right now is correct. Then we press OK. This is a straight line, a straight sketch. How we can generate a model? We can choose a surface. In the normal directions, and join a circle and stretch along the lines to get a model. So this direction is YZ. So we choose this one, YZ, and this is original point. We join a circle around here. Suppose the radius is 3 millimeters. We open the sketch. Use a circle started from original points. Press the left button and keep pressing and move the cursor to around 3 and leave the left button and press 3 and the left button radius 3. So it's okay. Now how to do the model? We have to pick the line first. Along the lines. Here. How to do it? By choose this button and swipe and filling to get a model. According to this rule, the pink color, and according to the round profile, the model on the screen already. But the diameter of the model is 10 millimeters, while we say the radius 3, the diameter supposed to be 6. Then press enter. Okay, then we press OK. The model on the screen already. Then we change the color by putting the cursor on top of it and press the left button and choose all looking and pick the color. To give a color, suppose cyan. Okay. This component is located on original points. We save it first. save another file as .prt and give a name tool. Yes. But the tool, this one should be combined with TCP original points. So we have to do assembly of this one. How to do it? We just close the file and open an assembly vacant file. And insert a component, only the last one. You can insert everything from J0, AJ0 to AJ6, or simply insert AJ6. Where is AJ6? The last component of the model. Okay, AJ6 in here. Open it and put it at its original points, AJ6. You can see the TCP original points. Mark the edge and press the left button of the mouse. You can see the center of the TCP original is located at 485 millimeters in X coordinates. The Y coordinate 0, the Z coordinate 720 millimeter is correct. Then we have to see this one and this one, and to locate our tool at 485 720, and we insert the tool and choose the tool, tool, and open it. First of all, we have to put it at its original points. That means at the Cartesian original points. And then cancel the fix. How to do it? Put the cursor at this line and press the left button of the mouse and choose floated. The fixed mark be removed. And then how to shift to these points? First of all, we have to pick the components and then use move the component function and pick from data XYZ. We have to key in before we get the value 485 and Z 720. Okay, you can see the tool original will join to the TCP original, and then make sure the tool right now is the incorrect position. Then we have to save PRT and IGS file. Then we have to remove the AJ6 by picking AJ6 and press the delete key of the keyboard and say yes. So only the tool on the screen. Then we have to save another file. The type is .prt. The name give another different tool name. We set it tool 1 and save it as PRT file. And then we save another file use the type IGS. The file name we keep its original R2. So we get r2.igs and save it. Yes. So after every components of the mechanism, including the tool, being saved into IGS file, then we can left SolidWorks and go into the polychance to translate all the component from IGS file to X file. We do one, for example, starting from the foundation. Press translate and choose import 3D geometry and choose IGS v5.3 via Okino ASCII file and choose the correct file folder. The D Aurotek, and the foundation is AJ0 IGS, and open the file. Okay. Yes. Start Scene Optimizer. Start. Yes. Okay, we get the foundation on the screen. Then we export 3D geometry. Use the rest file. And save it as positive normal direction. Okay. And give a file name AJ0A as positive normal direction. And save it. And then save X file. Export 3D geometry. The rest X file. Pick reverse orientation of all polygons and the normals, and pick free polygon normals to change all the direction into the opposite minus direction, and give the file name as aj0b.x and save it. After positive and negative saved, then we say scene and no saving, and import 3D geometry as the rest file from the Aurotek folder to get AJ0A positive. Open the file. Okay. Yes. And displayed AJ0A on the screen. And import 3D geometry as the X file. And import AJ0B, the negative part of the foundation, and open the file. Okay. Then AJ0A, AJ0B on the screen combine together, so it can reflect the lights from any direction, because each triangle surface, both sides are in. The color can be reflected to any direction. Then we combine this positive and the negative and export 3D geometry as the rest S file and with positive only. Okay. And give the file name AJ0 only. Then we can get the foundations X file. And with the same methods, we can do the AJ1. By input the AJ1.igs into the system and save the positive X file as AJ1A.x, and then save the negative AJ1B.x, and we say scene and reload aj1a.x and aj1b.x and save it as aj1. The aj2 as well, the same as well. We open the IGS file aj2.igs and display on the screen, and export X file, the positive parts as aj2a.x, the negative parts as aj2b.x, and reset scene, then reload aj2a.x and aj2b.x on the screen and save as X file aj2.x. The same way we can get aj3.x, aj4.x, aj5.x, aj6.x. The last one is the tool, r2.x. After all the X file of the components translate by polytrans from IGS file into X file, then we can copy s2.x, aj6.x, aj5.x until aj0.x into our CMS GAC data folder, and we can use this S file name feeding Excel CSV file. Now we're doing these demonstrations. We neglect the S file saving. Go into CMS GAC and the data. We choose r.start CSV, choose any robot as examples, and to change it into the one what we need. Suppose the previous displayed on the screen is robot T new. New is the new rules for RGB arrow and for limitation dummy.x. Okay, we choose robot TP new. Suppose we choose this one, R6T new. By press the right button of the mouse, duplicate, and change the folder DCMS GAC data, and choose the vacant position, and press the left button and stamp it up. We have the file name like this, and press the left button to change the file name as R6 A T new, and press twice of the left button and to change the contents of it. If the same, we keep it. If the difference, we change it. The foundation AJ0 X file, the mesh 0 object 0 attached to 0 attached to itself. We started feeding these items and left this one later. The AJ1.x, the mesh 1 object 1. Object 1 attached to foundation 0. AJ2X mesh 2 object 2. Object 2 attached to object 1. AJ3X mesh 3 object 3. Object 3 attached to object 2. AJ4.X mesh 4 object 4. Object 4 attached to object 3. AJ5 mesh 5 object 5. Object 5 attached to object 4. AJ6 mesh 6 object 6 attached to object 5. R2 mesh 7 object 7. Object 7 attached to object 6. The mesh 8 to mesh 13. The same object 8 to object 13. The 8 minus 3. Actually minus 4, 0, 1, 2 until 3. A minus this is the definition of the limitations. The translocate in this position is 4. 4 we have to minus 3, so divide 1. 1 is this one. The first axis of the roller. The limitation, the positive is y79 degrees. The minus is minus 179 degrees. So translocate 5 minus 3 is divided 2. AJ2 limitation. The positive is 87. The minus is minus 87. So the same until the last translocated 9 is to mark the positive and the negative limitation of 6 axis. The positive is 179.5 degrees. The negative is minus 179.5 degrees. The rest 3 use the standard rule. The X original 14 mesh 14 object attached to object 7. Object 7 is the tool itself, and the feeding translocate 99. Then RL will automatically to the TCP points. The mesh 15 YORG.X the same attached to 7 object attached to the tool, and the translate rotate feeding 99. The mesh 16 is Z original.X. The object is 16 as well, attached to the tool object 7 object, and the feeding translate rotate 99. Don't forget the 6-axis standard roller. The continue the last one we have to feeding 2. This is mechanism style. Okay, after feeding all the things is correct, we have to make sure the CSV is correct before doing any movements, any usage of the system. How to do it? We have to save it. Yes, we have to leave the file, the CSV file, and save it as A-iR6 new. Yes, yes. Okay, after saving, we open capk.gac and adopt the file we just fed in. How to do it? We just use the new function to remove, to clear the screen, and use scene input, and from dCMS GAC data to choose A-iR6 new. This is the file we just fed in, and open the old file. You can see displayed on the screen. Then in teach mode, we move the first joint in join mode, the J1 positive. You see the directions with the left hand rule. Turn around Z positive direction with the left hand rule. The J1 minus is this direction. The J2 turn around the Y positive with the left hand rule. You see the direction. The J3 positive turn around Y positive direction with the left hand rule. This J3 positive, and this is J3 negative, defined by CMS CAPP, our system. We talk already. If FNAC is different, the button 2 axis is the right hand rule. The rest 4 is left hand rule. For ITRT's robot controllers, all 6 axes all with the right hand rule. For J4, the left hand rule. The J5 and the J6. Okay, this is the join mode. Then we can put a cursor on the join mode positions anywhere and press the left button to change the system into Cartesian coordinate system. By control, by RGB arrow, this is X, this is Y, this is Z. The X positive should go this direction. Let me see. As press the X positive, you see it go this direction, and negative X, it go this direction. The Y positive, it go that direction. Y negative, it go this way. The Z positive go up. The Z minus go this way. While rotating X positive, X no movements. This point no movement. The rest will turning around the R arrow by right hand rule. The thumb point to the arrow direction. You see? And the Rx minus equal another direction. And Ry positive. You see? The Y arrow, no movements with right hand rule. And Rz positive. You see? And Rz minus. We talk already. We remove the duplicate, the complicated turning around, the showing, the circle by simply mark compare with visual component. In here, the robot settings, if we choose, we will mark select 0. Then we can add the teach mode to put the cursor to choose any join. Suppose this join, as we put the cursor on top of this component and press the left button, it will mark select 3. The third join be selected. In these moments, we can press the left button of the mouse and continue pressing the left button and move the cursor to the right. The join 3 will turn around the positive direction. As moving to the minus direction, the join 3 will turn the negative direction. Suppose we choose this join, press the left button of the mouse. In here, we select the number 1 join. Then we press the left button of the mouse and move the cursor. Continue pressing the left button and move the cursor to the right. Then the join 1 will turn around the positive direction, while we move the cursor to the negative, toward the left direction. The join 1 will turn to the minus direction. This is the way we think is better to demonstrate and to use as teaching more. To teaching the robot doing the actions is quite easy to use. Okay, the demonstrations to the end.
Chiao.